Hello guys, in this video I will be discussing um, module 9 lesson 2, sound and hearing waves. Okay, so when we say sound waves, it is a longitudinal wave in a medium. Longitudinal, di ba meron tayong two types, transverse saka longitudinal. Ang sound waves is a longitudinal wave. Sound waves which is audible to human ears is from the range 20 hertz to 20,000 hertz. So beyond that, hindi na natin maririnig. Above the range is ultrasonic, what we call ultrasonic, hindi na rin natin maririnig yan. Below the range is infrasonic, hindi na rin natin naririnig yan. Okay? There are few uh, computations that we are going to apply here in sound waves. One is the maximum pressure fluctuation. Okay, ang formula dyan ay P max is equals to BKA. B is the bulk modulus of the medium. K is the wave number, or what we we can compute at as 2 pi over the wavelength. Okay, A is the displacement amplitude. So in problem number 1, sabi dito, in a sinusoidal sound wave of moderate loudness, the maximum pressure variations are about 3.0 times 10 raised to negative 2 Pascal. Ayan. Find the corresponding maximum displacement. Ang hinahanap is yung A. If the frequency is 1,000 Hertz. In air, at normal atmospheric and density, the speed of sound is 344 meters per second. And the bulk modulus is 1.42 times 10 raised to 5. Okay, 1.42 times 10 raised to 5 Pascal. Okay, so hanapin natin yung amplitude. The pressure is equivalent to BKA. Meron tayong given pressure, meron tayong given bulk modulus. Okay. Ang K natin is can be solved as 2 pi over the wavelength. Okay. Ang wavelength, okay, wavelength, pwede natin kunin yan sa formula na V is equals to wavelength times the frequency. Okay. So, ang wavelength is V over F. So, V is 344 meters per second over the frequency na 1,000 hertz. And then, the amplitude. So, ang amplitude natin is equivalent sa 1.2 times 10 raised to negative 8 meters. Okay, so this is our final answer. Next, speed of sound can be computed as square root of the bulk modulus of the fluid over the density. Speed of sound in solid can be computed as square root of Young's modulus of the material over the density of the material. Okay, so for example, in problem number 2, sabi niya, a ship uses a sonar system to locate underwater objects. Find the speed of sound using, okay, the formula V square root of the bulk modulus over the density. And find the wavelength of a 262 Hz wave. Okay, makukuha natin, ang bulk modulus of water is equivalent sa 2.18 times 10 raised to 9. Okay, this is a property. And density of material is of the fluid is of water is 1,000, diba? So 2.18 times 10 raised to 9 over 1,000. So ang speed natin is nasa 1476.48 or simply 1480 meters per second. And kunin natin yung wavelength. Ang wavelength ay equivalent sa V over F. Ayan. So, V is equivalent sa 1480 over the 262 Hertz. So that is equivalent sa 5 point, tama ba? Kasi 'di ba ang velocity is ganyan. Okay, so tama. So 5.65 meters. Okay. So next, speed of sound in a gas. Ayan. So sabi niya dito, ang formula is gamma RT over M square root. Ayan. So find the speed of air at temperature of 20 degrees and find the range of wavelengths in air to which the human ear is sensitive. The mean molar mass for air is 28.8 times 10 raised to negative 3 and the ratio of heat capacity is G. So V is gamma is 1.4, R is 8.31, T is 20 plus 273 divided by 28.8 times 10 raised to negative 3. So let's compute. That is equivalent sa velocity na 344 meters per second. So that is the standard actually. So that's it. Thank you for watching.